So I will go very briefly through the policies and principles, both global and a little bit focus on Europe. As I said, several data management principles, you will be introduced to several of them, and we will also cover a little bit about data management plan. All of this is obviously very important when you are creating a digital twin. So GEO is the group on Earth observation, and the reason why we highlight them here is that it's a global organization that has influenced several data policies around the world, including the Copernicus data sharing principles. So it's an intergovernmental organization where, based on the volunteer contributions, and is dedicating to improve the availability, access, and use of Earth observations. And that covers satellites, everything in between when we measure from space to actually the interior of the Earth. So it was lacking this coordination. So the goal is that GEO shall then provide both information and coordinate the global Earth observation system. I will then. So just to give you a little bit of reference. From the very beginning, data sharing principles were included in the reference documents of GEO. I was part of writing those actually when they were written from 2004. So it's 20 years this year since they were developed. This you see here the latest strategic plan for GEO, and you see it's even more important it's regarded even more important that we are continuing to share data. So it's strengthening, and it's recorded in this strategy document, the value of open data sharing. I mentioned Copernicus. So the Copernicus data sharing principles or policy, the policy around that is actually based on the work that was done on governmental level in GEO. In Europe, we are continuing to develop the data sharing. It's strengthening through a series of political legislation, etc. And one of the important topics or the framework for discussing this now is data spaces. You will hear more about data spaces in this summer school also. There are several data spaces that are relevant for digital twin. Digital twin doesn't only contain Earth observations, but other types of data also. And the data spaces, I think there's like 16 different data spaces, including the Green Deal data space, which, Iliad is one of the Green Deal projects. And there's a series of updated the Data Act and the European Data Strategy, etc. They are all part of implementing those overall data sharing principles. And what are they? They are the three main principles, data sharing principles, and that is data, metadata, and products will be shared as open data by default. Open data by default. And by making them available as part of the GEOS data collection and open resources for everyone. So GEOS is the Global Earth Observing System of Systems. It's a federated system, just as Iliad is based on a federated system architecture and approach. And they should be without charge and restrictions on reuse, subject to the conditions of registration and attribution when the data are reused. The second one is where international instruments, national policies, and legislation preclude the data sharing as open data. Data should be made available with minimum restrictions on use and no more than the cost of reproduction and distribution. So I want you to note here that even though we say it should be open by default, we recognize that there are certain situations where you actually have to restrict the data. It can be, for instance, when you are publicizing, you publish your research, you are allowed to delay the publication of the data because you want to merit, you want to do your science and publish it before others will get access to it. And there might be security issues that also restrict the open sharing. But all shared data, products and metadata will be made available with minimum time delay. So those are the data sharing principles. These are very important to know about. I will go now very quickly through something that is increasingly important and specifically important actually in digital twins, and that's licenses. We need to have knowledge about the licenses because we need to know the right to access, use and share the data. We need to remove blocking points, uncertainties, permissions, heritage, and it enables innovation and reduce the risks also for businesses and research. And it's a part of a data management plan. And the simplest is the best. I just wanted to mention, and here I include these slides. You will see these slides. I will not go through all this, the detail here, but you see that this is the Open Geospatial Consortium, and you will hear from Piotr Zaborowski after me today on standards, but this is something that the OGC is working on, and we are working on it in Geo as well. So just the message here is, be aware of the licenses, and if you are creating new data, please do provide good information about what license you are issuing your data through. Now, we are starting to talk about the data management principles, and the starting point is the data life cycle. So here you see an example. And the data lifecycle management it refers to the policies, to the tools and internal training that helps dictate, the data life cycle. It's essentially the framework for managing how data is collected, cleaned, stored, used, and eventually deleted. So this is, you see an illustration of a data life cycle here. So the now famous data management principles of Geo, they are very, very powerful. So you see here, there's 10 of them, and I will try to go very quickly through them. So number one, discoverability, and you can compare this, if you know the FAIR principles, is findable, but all the data and associated metadata will be discoverable through catalogs and search engines, and data access and use conditions, including licenses, will be clearly indicated. As I said, licenses are an important part of data management principles. The second one is accessibility. The data will be accessible via online services, including at minimum direct download, but preferably user customizable services for visualization and computation. Encoding. Data will be structured using encodings that are widely accepted in target user communities and aligned with organizations' needs and observing methods, with preference given to non-proprietary international standards. And standards you will learn more about later. So that's usability. This is a usability set of principles. Data will be comprehensively documented, including all elements necessary to access, use, understand, and process, preferably via formal structured metadata based on international or community-approved standards. The extent possible, data will also be described in peer-reviewed publications referenced in the metadata record. We can come back to this. Provenance. Data will include provenance metadata. So provenance is where the data come from, who is the owner, the provider. indicating the origin and processing history of raw observations and derived product to ensure full traceability of the product chain. Quality control. Data will be quality controlled and results of quality control shall be indicated in metadata. Data made available in advance of quality control will be flagged in metadata as unchecked. So information about the quality is super important. Preservation. Data will be protected from loss and preserved for future use. Preservation planning will be for the long term and include guidelines for loss prevention, retention schedules, and disposal of transfer procedures. This is important, for instance, for reusability, for using the data across different disciplines, etc. Verification. Data and associated metadata held in data management system will be periodically verified to ensure integrity, authenticity, and readability. And last but not least, well, it's not quite in the next last, review and processing. Data will be managed to perform corrections and updates in accordance with reviews and to enable reprocessing as appropriate. Where applicable, this shall follow established and agreed procedures. This is specifically relevant if you have, for instance, real-time data and you need to process them to get rid of some I know the space-based ones that are you have atmospheric correction, etc., and you need to reprocess the data to get the quality you want. But also reprocessing for other purposes is highly relevant. This is the last one, identifiers. Data will be assigned appropriate persistent, resolvable identifier to enable documents to cite the data on which they are based and to enable data providers to receive acknowledgement of use of their data. So there you have the principles. Now, to follow this, we have developed in GEO guidelines, so implementation guidelines, and the main headings here. And if you are working on data, this is a very valuable link that you get here and a document that will help you enormously if you are, even if you are advanced or totally new. So the guidelines contain 5 main headings: discoverability, accessibility, usability, preservation, and curation. And you see you will recognize the color coding. So these are very valuable documents where you actually go in more detail on how to execute, to implement these management plans. Let me see there. Yes. So you would like also to know if you are compliant with these principles. And there are 3 levels, just to say that, 3 levels of conformance. The self-assessment and declaration, so you evaluate yourself and tell the world your finding. Then you can rely on peer review and automated conformance testing. There are some software that do automated conformance testing. And then finally, certification by third party. So this is a way of check if you are compliant. Now, we go over to the next data management principles, the FAIR principles. You will recognize findable and accessible. Interoperable is, I will compare, you be patient, you will see a comparison between GEO and FAIR shortly, and reusable. So the FAIR is targeted for research data and services. GEO, remember, is mainly for the Earth observations. The FAIR principles are covering a more a wider field, but you will see that they complement each other quite nicely. So FAIR is again mentioned metadata and data that should be easy to find for both humans and computers. It should be obviously accessible. Once the users find the required data, he or she needs to know how they can be accessed, possibly using authentication and authorization. And it need interoperable. They need to be interoperable, and we will cover and discuss more about interoperability and different levels of interoperability later. But the data usually need to be integrated with other data. And in addition, the data need to interoperate with applications or workflows for analysis, storage, and processing. And finally, reusable and reproducible. Metadata and data should be well described so that they can be replicated and or combined in different settings. So you see that there are many commonalities, and here is a comparison for you. We had done an exercise of comparing them. What geo principles, data sharing principle goes further with respect to open by default, and also available with minimum restrictions at no more than the cost of the reproduction and distribution. This is explicitly said along with the minimum time delay. So there are more comparisons here, but I just wanted to show you that. And then trust principles, of course, to make the FAIR principles and the other principles to apply that, you also need to preserve them over time, and that requires trustworthy digital repositories. And these will need to have sustainable governance, an organizational framework, a reliable infrastructure, and comprehensive policy supporting community agreed practices. So you see here, they are complementing the two other, some overlap, but mostly complementing. And last but not least, I wanted to talk about the CARE principles. The CARE principles was developed by the indigenous community, and they complement the other principles, and they are related more to a specific community. They concern data collection, access management, and their ethical use and respect of the indigenous people, nations, and community. So I will go quickly. I'm looking at the time, so I will go a little bit faster here. So here you see what the CARE stands for. It's inclusive development and innovation, for improved governance and citizen engagement, for equitable outcomes, recognizing rights and interest, and data for governance and governance of data. So the indigenous people are very concerned with having control over the governance of the data, and for a positive relationship, so respect for both the provider and the user, expanding capabilities and capacity, and including indigenous language and worldview, and maximizing harm and minimizing harm and maximizing benefit. And it should be for justice and for future use. So this is really important for data from and for indigenous people. Then, when you are creating a digital twin, obviously, as with all projects, you need to have a data management plan. And if you follow the data management principles, you will almost automatically have a data management plan. So the definition of a data management plan is that you have a living document that outlines how data should be handled throughout the life cycle of a project. And you should consider many aspects of metadata and data generation, management, preservation, storage, dissemination. And it addresses compliance with policies and licenses, preparing the data management for reuse in the future. So you recognize the principles and what goes into a data management plan here. And the context is a regulatory and required often by national and international funding agency, for instance, the European Commission. It's also for educational purposes, that it familiarizes young students with Earth observation data sharing and data management principles. And it also functions as an internal brainstorm, enhancing the team's implicit knowledge of sharing principles. and it works with several of the data sharing, the data sharing principles families. So geo, fair, and care, and trust. And there are some reporting tools available, and I will highly recommend that you visit this the Geo Knowledge Hub, where you can find the Geodata Management Self-Assessment Tool. And it's produced mainly by Min Paris Tech. So you see here, and you can see many examples from an E-Shape project, which is its applications and services. And so you can have a lot of best practices on how they are using this tool. What is important is that when you start out with your data, you might have limited information. You don't really understand everything about your data to begin with. Now, what this tool allows you is that you can start to do the best you can to fill in this form, this table, and then after a year or two, you can do the same rehearsal again, the exercise again, and you will be discovering that you are improving. You see the trajectory of your learning about the data, and you gradually improve the data, the information about the data, and thus this is a good data management tool. Data management tool, yeah. Very quickly, in Geo, we go beyond now open data sharing. And I think this is related also to open science. In Geo, it's not only about science, so we call it open knowledge. And you recognize open access, open data. But you can also make note here of citizen and participatory science as part of open knowledge statement. Open science, of course, open reproducible research, again, following all the principles, this will be enabled. Open software, infrastructure, and hardware is also included in open knowledge. Open education, open evaluation, and diversity of knowledge is also included. So you see, we are moving more and more towards openness and traceability and transparency. And this might be perceived as a challenge with respect to business models, but as a matter of fact, it's more enabling more business than the other way. So the takeaway here is that data is important, goes without saying, is pivotal, of course, when you are making a digital twin, and sharing the data and managing it in the best way, including ethical considerations, reveal its value whatever data type and domain. And this, might I add, is particularly important to be aware of, this ethical issues now that we are doing more and more artificial intelligence. So I think you really should make note of this. Assessing the compliance to sharing and management principle is crucial, so that you know what you're doing. Several principles families exist and are applicable for Earth observation domains, and also the combination of data types that goes into a digital twin, I might add. Reporting tools are available to report about compliance to data management principles, both automatic ones and other different levels of compliance measurements. The benefits is that you support data governance toward a unified referential. It fosters research and innovation, and it increased data value through following the data management principles, as many more can use it. So it's like with the industrial data. This was my last slide, and here you can reach me and ask me questions if you like also later. But yes, I think in interest of time, I will rather stop here and then open the floor for questions if there are any. Thank you.
Thank you. Do we have any questions for Bente?
Hi, how are you? Well, it's not indeed a question, but something that I would like also to see is how to put in practice all these principle, all this FAIR principle, because it's very difficult. We collect a lot of different kind of data, for example, physics data, biological data, etc., etc., etc. So, for example, when we talk about interoperability, how to share the data, etc., etc., we need to follow different standards, protocols, or even procedures. So, how to, how to share all our data with the community. For instance, if you are developing a data architecture, but in your own institute, for instance, and you need to share your data, for example, with EMODNet or whatever. So, well, I would like also to hear from you your suggestions in order to how can we create our data spaces, but in the face of the creation, how to do this in order to later not doing an extra effort to connect all our space with all this European initiative, etc., etc., etc. So maybe having a discussion about it, will be very, very interesting, that. But it's not indeed a question, it's just suggestions and etc., etc., discussion. Thank you.
Thank you so much for actually that question, because so a very, very quick advice is that when you make a list of all the data that you need in your application or the analytics that you are doing, the model, whatever, and you have many different types of data, as you say, the important thing, the starting point is actually to list them and describe the format you have the data on, where they are laying, in which repository they are currently, which standards you are using, carefully noting down the metadata, following those simple things to begin with, that will give you a head start. And then, as I said, I will put that in the chat, actually, the link to that self-assessment tool, because I think you will find that schema that it's an Excel. Currently, it's Excel, so it's very manual right now. But even the most experienced data managers found this very simple tool very useful, the self-assessment tool. I will provide a link. I did it in the slides also, but I will provide that link. I think you will find some good advice there.
Thank you. Thank you, Bente.